Hello, I'm Lee, student from the System Planning Lab. Today, I would like to share my research on user-centered customization of in-vehicle displays. As autonomous driving technologies rapidly evolves, drivers will have more free time. In June, the experiment involved participants customizing 4 types of screens while completing navigation tasks in a virtual autonomous driving environment. A total of 30 participants took part in this experiment. Interestingly, 1/4 of the participants had little to no driving experience. After months of data collection, we obtained 3D position and size data for the in-vehicle displays. Initially, the data seemed difficult to organize. However, thanks to Milestone suggestion, we used Python to generate cluster plots, which clearly revealed participants' preferred display positions. Next, I applied the consensus formula by Vatavu and Walbrock 2015 to calculate the consistency score for each display. Higher scores indicated greater agreement among participants on the same display position and size. By comparing the consensus scores of the 4 display devices, it was found that the dashboard had the highest consistency score, with its data points being highly concentrated in the plot. In contrast, A, B, and D had relatively lower consistency scores. Interestingly, the C dashboard also had the highest consistency score in terms of display size selection. I can identify the optimal position and size for each in-vehicle display. The optimal position for the A portrait display is slightly left of the center line in the driving space. Participant 28 commented, "This position makes it easier to swipe and switch content." For the B floating display, there was a divergence in user preferences. 7 participants selected the central, while 6 chose the passenger side position. Participant 29 mentioned, "Placing it on the passenger side makes it easier to share content." The consensus score agreement rate for the dashboard was 0.446, indicating that participants' choices were highly concentrated in this area. Other studies have also shown that the dashboard is a familiar display method, which makes it convenient for viewing information such as speed and time, indirectly supporting the rationale behind this preference. When analyzing the consistency scores for the HERT-E, we also observed some divergence, indicating that participants may have more varied opinions when it comes to newer display devices. Then, I also combined the size data for the 4 optimal positions to create a library of flat and 3D models. This guideline can serve as a valuable reference for future in-vehicle display layouts. Reflecting on my previous 2 experiments, the first part compared which in-vehicle display was optimal for manual versus autonomous driving. The second part addressed spatial constraints by using a virtual driving platform to define the best display combination. Now, this experiment allows users to customize the layout and size, narrowing the research focus and enabling users to decide the optimal combination of 4 displays. These 3 experiments form a cohesive research framework. What is the best? Best does not equal best now. The best is customization.